Hey everyone, Mr. Houck here. In today's video, we're going to be looking at the law of signs, the ambiguous case. Let's go ahead and get started. So in the previous lesson, we went ahead and established the law of signs, which can be used to solve oblique triangles. And remember that we had to fall in a few different specific scenarios in order to be able to use the law of signs. One was angle, angle, side, so we had to be given a triangle with two angles and a non-included side. Another scenario where we could use the law of signs was angle, side, angle, where we had two angles in the included side. And then the third scenario, which we didn't work with much last, is what we call the ambiguous case, where you're given two sides and a non-included angle. And the reason that we call this the ambiguous case is because there's a lot of different possibilities that could pop up. We could run into a scenario where there's really only one triangle solution, like normal. You can run into a scenario where there is no triangle that's possible, or you could also run into the scenario where two different triangles are actually possible, two different solutions. So we're going to explore the different scenarios, and it turns out there's actually 6 of them, 6 different scenarios with the ambiguous case, and we're going to look at examples of how we could solve these problems that fall under the ambiguous case. So the first case that we're going to talk about is the case where no possible triangle exists. And something that I need to stress very heavily here, and it's very important that we all understand this, is that in each of the examples that we're going to be looking at, angle A, is going to represent the angle that you are provided. It's representing the non-included angle, and lowercase a is going to represent the side opposite of the angle provided. Now, it's important to realize that in these examples, we're using angle A, but in actual problems, it might not be angle A. You might be given angle B and side B, and then you would need to, when going through and working these problems, you need to be thinking, okay, well, maybe B was the angle that you were given, and lowercase b is the side we need to be examining. So just keep that in mind constantly. A is the angle you're provided, lowercase a is the side opposite of that angle, and B is going to be the angle that's provided that is not opposite of the angle that's provided. Okay? So, the first case, the case where no triangle exists. Well, there's actually two possibilities, two scenarios that this falls into. So let's say that we're given angle A is an acute angle, and that side A is less than h. And remember, h was the altitude that we dropped that's perpendicular to the opposite side. So in the case where you have an acute triangle, or at least an acute angle A, an acute angle that you're given, if the side opposite of it is smaller than the altitude that would be dropped right here, then this is actually an impossible triangle. It's not a triangle at all. So this is a case where no triangle exists. Another example of no triangle exists is one where we have the angle given to us is an obtuse angle. So notice here, angle A is an obtuse angle, and if angle A is an obtuse angle and the side across from angle A is smaller or equal to the side that's provided that's not across from the angle given, which again we're calling B here, but it doesn't have to be B. If we fall into this scenario, then this is also an impossible triangle. And we'll see some examples of this later on. All right, now let's look at the case where only one triangle exists. And there's actually 3 scenarios that we could fall into. So let's say that the angle that you're given is an acute angle, and let's say that the angle opposite of that acute angle is bigger than the side opposite of the given angle is bigger than the other side that's given, which is also bigger than the altitude h. Well, if we fall into that scenario, then we have a triangle, or we fall into a scenario that only has one solution, only one triangle is possible. Also, let's say again, the angle given is an acute angle, and let's say that this time, the side opposite of the angle given turns out to be equal or the same as the altitude h. Well, then not only do we have one triangle, but we actually have one right triangle as our solution. And then let's also look at the scenario where the angle given is an obtuse angle. Well, if you have an obtuse angle and the side opposite of that given obtuse angle is larger than the other side that you're given, then you would also have only one possible triangle solution. And now let's look at the case of 2 possible triangle solutions. So let's say that A is an acute angle, So the angle that you're given is cute. And let's say that in this scenario, the side opposite of that given angle, which is A here, let's say that A is bigger than the altitude that gets dropped, but A is smaller than the other side that's provided to you. Well, in this case, there's actually two possible triangles. One right here, you see right there, kind of sloppily traced in that red laser pointer. That's one possible triangle. But then there's also the triangle right here. Notice that, angle A is staying the same in both. Notice that side A is staying the same length. And notice that side B is also staying the same length. So it's two possible triangles given the exact same information, angle A, side A, and another side B. Two possible triangles. So to kind of summarize all that up, we have this nice little table right here. And this little table can be a quick little reference. But again, I can't stress enough that we understand that where we see angle A here in all these situations, in practice, this is not always going to be angle A. It's the angle that's given to you. So let's say that you're given angle C. Then you would want to say C is acute, and all the lowercase a's you'd want to replace with lowercase c's. Okay? And also in this scenario, B is always the other side that you're given, the side that's not opposite of the angle that you're given. Now you're going to notice that in a lot of these problems, or in a lot of these scenarios, we have to be able to understand h, the length of the altitude. Well, to calculate the length of the altitude is always going to be the sine of the angle you're given multiplied by the side that is not across from the angle that you're given. Okay? And let's see some examples of that. So all 5 of these examples, in the notes, there was plenty of space here, but actually, for me, this actually isn't enough space. I'm going to show a lot of work here. So I'm going to show all my work on the following pages, okay? You might need more space than what's actually provided to you because some of these problems take up quite a bit of space. All right, so here's problem number 1. We're given the measure of angle B is 124 degrees, we're given A is 31, and we're given that B is 34. So first thing that we want to notice is that this given angle, angle B, is an obtuse angle. Now, notice that across from the angle that we're given, we have 34, and 34 is bigger than the side that's not across from the given angle. So let's go back and look at those little scenarios here. So we can see obtuse angle, and the angle or the side that's across from the given angle is bigger than the side that's not across from the given angle. So this falls into a one triangle scenario. What this means is that if we use the law of sines, we will get the one and only solution. So let's use the law of sines to get our one triangle solution. By the way, if you've never seen those little 3 dots here in the shape of a triangle, that means therefore. So given this information, therefore we have a one triangle solution. So let's start with what I think is the first appropriate calculation. We're going to look at the information given to us, which is this right here. Notice we have angle B, side B, and side A. That tells me to use the law of sines. Sine of angle A over A equals sine of angle B over B. Plug in the pieces that you know, and cross multiply. After cross multiplying, we have 34 times the sine of angle A equals 31 times the sine of 124 degrees, and then simply divide both sides by 34. And notice we get this right here. Sine of A equals 31 times the sine of 124 degrees over 34. Notice I'm not calculating anything yet. I don't want to have to start rounding yet. I don't want to round, honestly, until the very end when I have to. So we're trying to figure out what angle A is. Well, let's take the inverse sine of both sides. So we get that A is the inverse sine of 31 times the sine of 124 degrees divided by 34. Plug that into a calculator, make sure your calculator is set to degrees, and you will get the angle A is approximately 49.1 degrees. Okay, so what next? Well, now that we know angle A, and we already knew angle B, then we can find angle C. We know that the angles of a triangle add up to 180, so angle C is 180 degrees. minus angle A and angle B. And that's going to give us that the measure of angle C is 6.9 degrees. And once we know that, then we can set up, using the law of sines, our equation to find side C. So we have sine of angle B over B equals sine of angle C over C. Set up, plug in the pieces, cross multiply, isolate for C, and we get that C is about 4.9. And now we've solved our one and only triangle solution. All right, scenario number 2. Now we have measure of angle A is 134 degrees, so we have another obtuse triangle. We have side C is 33, and side A equals 4. Now right off the bat, before I even look at anything, there's some red flags that are going up here. I can already tell this is actually an impossible scenario. And the reason I can tell is because 134 degrees, this is definitely going to be the largest degree measure. Take note that in an obtuse triangle, there's only one angle that's allowed to be bigger than 90 degrees. And we know by the way that sides and angles work that the largest side is always across from the largest degree measure. Well, if 134 is going to have to be the largest degree, well, notice the side across from it is saying that it's 4. That doesn't make any sense. So we can already tell that this is an impossible scenario, but let's also see why with our little table that we set up. So first off, we have an obtuse triangle, and notice the side across from the given angle being 134 degrees, side across from it being 4, is smaller than the other given side. Well, let's go back and look at that table. Okay, so we fall into this scenario right here. Angle that was given to us is obtuse, but the side across from the obtuse angle is smaller than or equal to the side not across from the obtuse angle, which doesn't make any sense. Therefore, we have an impossible scenario. This triangle, or this isn't a triangle, really, there is no triangle solution. All right, let's look at number 3 here. You can kind of see from the solution that I have, forgot to erase the solution, we can tell there's going to be a solution, but let's see why. So here's what we know. We know that the given angle to us is acute. The given angle, measure of angle B is 34 degrees. We can see that A is 13 and B is 16. And what's important here is that since the given angle was angle B, the side across from it, 16. So if we go back to our chart here, right here, so we see that angle A is acute, so we fall into either here, 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 or here, the two triangle solutions. And then we saw that the angle across from, or the side across from the angle that we were given, we saw that it was bigger than the side that wasn't across from it. So that automatically takes out this scenario, it takes out this scenario, and this scenario. We're left with a one triangle solution here. Okay, so that's what we end up running into. We have one triangle solution. So let's use the law of sines. First things first, let's go ahead and figure out one of our missing angles. So we have the information we're given. We have we have angle B and side B. So I know that's going to be part of our equation. And I'm going to go ahead and, since we have side A, the only thing we can really do is find angle A. So I go about setting that up, plug in the pieces, isolate for sine of A, and then of course take the inverse sine of both sides to figure out what angle A is going to be. Next, now that we have two of the angles, we can use the fact that triangles add up to 180 degrees for their angles. That helps us find the third angle, angle C. And once we know angle C, all we're missing is side C. We can really set up a number of equations here. I decided to do sine of angle B over B equals sine of angle C over C. The reason I decided to use sine of angle B over B is because it was the original given information and nothing here has been rounded, okay? Earlier in the problem, step 1 here, where we found angle A, this 27 degrees is actually slightly rounded. It was something like 27.0 something. So it's a little bit rounded. Even though it's not rounded much, if you can avoid using information that has already been rounded, it just helps you be that much more accurate. So either way, this is how I set up the law of sines. We go through the normal steps to isolate for C, and we get this side C is about 25. And now we have the entire triangle solved. All right. Scenario 4. We're given measure of angle A is 33 degrees. We're given that C is 34 and the A is 13. So again, we have, here's the given angle. Here is the side across from the given angle. And this is the side not across from the given angle. So let's see what we have here. The given angle is acute, okay? This is one of those scenarios, you know, when you calculate, or not when you calculate, but rather when you're given an acute angle as one of your given pieces, you want to go ahead and solve for h. Because if you look back at the little table, notice that for every acute angle, h is part of the calculation. And again, we talked about how to find h. It's the sine of the given angle multiplied by the side not across from the given angle. So in this problem, I went ahead and found h. So 34, the side not across from the given angle, times the sine of 33, the angle that was given to us, that's about 18.5. Now notice that the side across from the given angle, which is 13, is smaller than the length of that altitude, 18.5. And if we go and we look at our little table there, well, this means that it is an impossible triangle. See again here, A is acute, so the angle given is acute. We fell into that scenario. And the side across from the angle given was less than the actual altitude length itself. So that's an example of an impossible triangle. Therefore, no triangle solution. And you can probably guess what the last example is going to be. We haven't seen an example where we actually have two different triangles that satisfy the given information. So this last problem is going to be an example of that. So let's look at the information given so we can see how we would identify this if we run into our own problem. So the measure of angle A is 33 degrees, C is 21, and A is 15. So 33 degrees, there's our given angle. The side across from the given angle is 15, and the side not across from the given angle is 21. So let's examine that information. Again, we see that we have an acute angle. I'm going to go ahead and calculate h. So 21, the side not across from the given angle, times the sine of the given angle, gives us about 11.4. So notice that the side not across from the given angle is the largest side. It's bigger than the side across from the given angle, and the side across from the given angle is bigger than h, the length of the altitude. So that's the exact scenario we would have to fall in to have a two-triangle solution. Side not across from the given angle is the biggest. Side across from the given angle is in the middle. And that altitude h is the smallest. So that's the exact scenario that we fall into here. So how would we go about figuring this out? Well, let's use the law of sines. Let's kind of treat the first triangle as if it was a normal problem. So we would do that by, trying to find one of the missing angles. In this case, the missing angle would have to be C, because we already know angle A, we know side A, and we know side C, so the only logical step is to find angle C. Well, we go ahead and set up that equation using the law of sines, cross multiply, do everything we need to isolate for C, and we get that angle C is about 49.7 degrees. Okay? Well, let's continue solving this. So now we know angle C, we know angle A. Next logical step is to find the measure of angle B. So 180 degrees minus the angles we already know, we get that angle B is about 97.3 degrees. And then finally, we set up our last ratio using the law of sines right here to find angle B. We've done several problems like this already, so I'm not going to talk us through it here. But this is our first potential triangle solution. And the question is, how do we now find the second possible triangle solution? Well, it actually comes from this angle C that we found right here. So when we use the law of sines to find angle C, well, if we go back to that picture right here, notice that this angle right here can either be an acute angle or it can be its complement, an obtuse angle. So what that means is the two different angles that would show up right here, they're complements of each other, meaning that these two angles would have to add up to 180 degrees. So if we look at this angle right here, 49.7 degrees, well, its complement would be, if we subtracted it from 180, 130.3 degrees. So the other possible degree measure for angle C is 130.3. And this is what we'll use instead of 49.7 degrees to calculate the second possible triangle solution. All right, so once we have that though, we know that, angle A is still 33 degrees. Our new second possible angle C is 130.3, and we know to subtract those from 180, and we get that the other possible angle B is 16.7 degrees, and then now we're one step away. Use the law of sines. We want to find the missing other side for B, and we cross multiply, solve for B, all that fun stuff, and we get that the other possible measure for B is 7.9. Okay, so again, if you run in this scenario where you can verify that there are two different possible triangles, once you have found this angle measure right here, find its complement, and that's going to get you the angle measure to use for your other second possible triangle solution.